All right, I think we're going to get started here. It's just a little bit after 6:30. My name is Hayden. I'm a meteorologist with the Weather Service in Morehead City. Really appreciate you joining us tonight. We're getting well into spring. It's a gorgeous night. You would probably rather be outside than inside. So I really appreciate you joining us. Before we get started, a couple of things I want to point out. I know we have a few new folks that have just logged in. In your handout section, there's two things. Number one is your certificate. Go ahead and print that out, save it off for you. The second thing is a PDF of our presentation. I do not expect any technical difficulties, but just in case, have that PDF handy so that you can follow along. If we have any internet issues, if we cut out, just log back in because we do have a backup for our internet tonight. I am at home. Usually the home internet is good, but I do have a backup just in case. So just kind of keep that in mind since we're doing this virtually. The other thing I want to mention is we're going to have some interaction and some poll questions. So please answer those polls as they come because we want to hear from you because we kind of tailor each class a little differently, just really depending on how you all respond. I mentioned this before for those that have logged on. Your microphones have been muted, so you don't have to worry about any background noise. You can enlarge this presentation a couple different ways. If you're watching on a home computer, you'll see myself, you'll see the PowerPoint. And the PowerPoint should be a little bigger than the webcam. But if you still can't read the text, you can stretch it out and actually go full screen with the presentation. Number two, if you're on a mobile device, you can swipe left or right, and that will make the presentation larger so that you don't even have to see me at all. So those are some things that can enhance your presentation for tonight. As far as questions go, at any point, if something is not clear, you have a question about it, just ask it in the questions tab of the webinar. It's just me tonight, so I probably won't get to those answers until the end. If I happen to look over and see something that's relevant, I'll try to answer it right away, but we'll probably do the Q&A at the end. If you want to talk to me, this will definitely be at the end. Raise your hand. I will click on you, unmute your microphone. Then you'll have to do the same thing on your end. It's kind of a double layer of protection, and you can go ahead and ask that question. I already mentioned that in the handout section, you can get your certificate and a copy of the PDF itself. And if you know anybody that missed it, you want to review this again, you can certainly do so on our YouTube channel, which we'll share with you in a follow-up email tomorrow. As I mentioned, you can communicate with us. If you don't see that box, you're wondering what am I talking about, just hit that orange arrow and that will expand it for you. I know some folks, when you log in, it defaults to the small skinny version. Just click the orange arrow and that will certainly help things out. So welcome to our class. I keep making this mistake. This is our 4th year of doing this. So we've been doing this for a while now. In a normal year, usually a couple times a season, we do a virtual option. It's easier for folks to watch it from their own homes. You will now be entered in our spotter database. We have all the information we need from what you signed up with. So sit back and enjoy. The class itself is about 50 minutes, so we're talking maybe about 7:15 we should be done. One last thing I should mention about the end of the class, that is your time to ask questions. So if you want to log off, that's perfectly fine, but we will certainly turn it over to you for some questions. So before I get too much further into the talk itself, a couple questions to ask you, specifically if you've been with us before. I'm kind of curious for those folks that are viewing us maybe for the first time, is this your first spotter class or have you been with us before? And the reason why I always ask this is it's good to know the audience. So anytime we try to do a class, we tailor it a little bit depending on if it's your first time. So we'll give about another 10 seconds for you to vote, and then we'll show you the results. So just click yes or no. Is this your first class with us or not? It looks like everybody has voted. So I'll share the results. And this is always good news. We have a mix. The majority, this is your first time. So welcome, 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 welcome. Really appreciate you taking the time to join us. And then we have some in the audience that have taken the class before, and that's great. If you have taken it before or this is your first time, we always recommend every couple of years to kind of take a refresher because things do change from year to year. And we certainly do want you to stay updated on the latest procedures. One thing I'm not going to ask you as a poll, But at any point, via the questions section, just so you're more familiar with how to ask a question, comment in there and comment with the city you're watching from. So I know we have a lot of folks from the Morehead City area, and what I mean by that, roughly a 3 to 4 hour radius around that area. And then we do have some folks from outside of North Carolina. Always like to hear from you as well. So in the question section, just send me a little message. Just chime in with the city that you're watching from tonight, and we would certainly appreciate that. So welcome to all. The topics that we're going to go over a little bit about who the Weather Service is. We're going to go over SKYWARN, what the program is, all about thunderstorms. That includes things like squall lines, flash floods, tornadoes. And then we're going to really hit home on the review of the spotter procedures. And for you that have been to the class before, this is similar. We always talk about who the Weather Service is, why we need spotters, and then we go into the specific topic. At the end of tonight, we're going to talk about some other opportunities you do have for training beyond just this class. We try to make this a year-round activity, and we try to make it a lot of fun and keep you engaged 24/7. A couple things to keep in mind. Don't expect to absorb all of this. This is not a class. We do give you some science. That's just for your own knowledge. You're not going to be quizzed on it when you call us. I do have a couple quiz questions at the end just to reinforce some things. But what we really want you to focus on, report to us when severe weather happens. And when you do so, knowing what to report, how to report, and when. That's all I want you to get out of the class, and what the Weather Service is about. As long as you understand what the Weather Service is about, when you should call in, and the types of things you should call in, that is all that we're concerned with. If you understand the science, that's great. That's gravy. That's an added bonus. So a little bit about the Weather Service. Our main mission is to protect life and property. We do that through the issuance of watches and warnings, and we do that by issuing these to the general public so they know about things like tornadoes, severe weather, hail, and high winds. We also issue climate forecasts, so that you can prepare for upcoming weather. We have a lot of different offices across the country. This little jigsaw map shows every local office. We actually have over 100 offices in the country itself. We're going to mainly be focused on Eastern North Carolina because that's where we're from. This is my little mental note. If you've signed up and you're from outside the area, that's not a problem at all. What we ask you to do is, at the end of this class, just contact your local office. I can help you with that if you need help. The reporting procedures are the same. What to report, when to report. The how is going to be different. The 800 number, the email, all that's going to be a little bit different. So you're going to want your local number to call, and I can help you get hooked up with that. Elizabeth, thank you for commenting in the question part. She's watching from Jacksonville tonight. Again, if you're just joining us, in the question section, kind of a little test so you can learn how the GoTo webinar works. Comment, where are you watching us from tonight? Super curious. I know we got a lot of folks logged in from all over the state of North Carolina. As I mentioned off the top, I am out of the Morehead City office. This is the area we cover. Roughly the eastern quarter of North Carolina, everywhere shaded in yellow. And you'll notice that yellow area does include the local water. This is out to 20 miles. So Bogue Sound, Pamlico Sound, Albemarle, any of the local rivers, and then out into the ocean about 20 miles. You'll notice there is a blue shaded area. We actually do warnings out to 60 miles as well. So we have a pretty big chunk of not only land areas, but also out into the water itself. So if you've ever been out to the beach, you've been lucky enough to be on a boat, you have been served by the Weather Service for a local forecast. You'll notice there's no shading down toward Wilmington, Raleigh, or even Richmond, Virginia. Those are those other offices I showed you. The Wakefield office covers up in Northeast North Carolina. Raleigh covers the central part of the state, and Wilmington covers the southeast part of the state down near the South Carolina line. Any local office is open 24/7, so there's always at least 2 of us there. Usually, if you visit us on a weeknight or an overnight shift, only 2 of us there. If you visit us during a hurricane, which you probably wouldn't be doing, this is what our staff looks like. We're all there. We're a brick reinforced building that's up in elevation, so we are located in a safe place. We do have hurricane shutters. That is my office. I have a nice, inflatable bed so I can sleep in it, and we're well secured. So we stay in place when the weather gets bad. Our goal, again, is mission is protection of life and property, so we stay when the weather gets bad, but we are in a safe location. So that's a little bit about the Weather Service. The easiest way to get that information is weather.gov, and we're going to show you some slides on our internet website here coming up. As far as the SKYWARN program is about, it's a volunteer program run by the Weather Service, and the whole goal is to provide ground truth reports of significant weather. What does ground truth mean? What is happening at the ground, or what is not happening? So our radar, our satellite, very sophisticated, but it's looking up in the atmosphere, and it can tell us a lot. And as a meteorologist, we can surmise a lot based on that equipment. But the trained spotter actually tells us what's happening at his or her house. How big is the hail? How strong are the winds? Is there a tornado, or is it a funnel cloud? That type of thing. And this really assists us in the warning decision process. And what we mean by that is, as a meteorologist, I have to make decisions on issuing warnings, whether or not the storm, it's in the middle of the night and I don't have a lot of reports, or it's the middle of the day and I have a lot of reports. So we have a lot of ways to get information, and the spotters really help us determine how bad a storm is. A good example is, let's say we're watching a thunderstorm. It looks really bad on radar, not bad enough to issue a warning yet, and it goes over Jacksonville. And I picked on Jacksonville because I can see Michael's watching from Jacksonville and Sarah's watching from New Bern. Let's say it goes over Jacksonville. Michael calls me, Elizabeth calls me, and says it's nickel-sized hail. Then a little bit farther east, that storm goes over Sarah up in New Bern. Now I know that the storm has strengthened on radar. Michael and Elizabeth have already said it's nickel-sized hail. Since it got stronger, I'm confident that the hail is larger. I'm going to go ahead and issue that warning. So those reports help us gauge how bad a storm is. The flip side would be, we think it's really bad. We might even be close to issuing a warning, and then we get multiple reports that it's just not as bad as we think. In that case, we don't issue the warning, and that's good. We're not crying wolf. We're not warning people when they don't need to be warned. So the trained eye of the storm spotter is still our greatest asset. We have fantastic equipment. The new satellite technology over the last couple of years is tremendous, as is Doppler radar. But again, a trained spotter can really help us out to know what's going on at the ground itself. A couple definitions we want to go over before we mention, once we get into severe weather, you need to know this terminology, watches, warnings, and what a severe thunderstorm is. A watch is issued when conditions are favorable for that to happen. Tornadoes, winter storms, hurricanes. It means all the ingredients are there. It hasn't happened yet, but you should start thinking about getting ready for it, that type of thing. A warning is issued when it's imminent. It's already occurring, or it's about to occur. Examples would be tornado warnings, severe thunderstorm warnings. That's when you need to take the action. Preparation's over with, time to seek shelter, that type of thing. I love cooking, I like baking, and I like those analogies. So the watch would be, you go downstairs, the brownie box or the cake mix is on the counter. It's in a bowl, the eggs are out, the milk or the oil is in a measuring cup, and the oven's preheating. You know what's probably going to happen. All the ingredients are there. The cake hasn't been made yet, but you can start thinking that, hey, probably going to have cake or brownies today. The warning is the timer on the oven's going off. You can smell it. You can turn the oven light on and see the brownies. It's happening. You need to be ready to have some brownies or cake. And if you couldn't just tell, I just had dinner and we did make some cookies tonight. So that's why I'm talking dessert. But the point of that is, watch means possible. Warning means it's going to happen. So those are important points to remember. As far as a severe thunderstorm goes, that is something that produces 1-inch diameter hail and or winds 58 miles per hour or greater. And we don't just make up those numbers. That's roughly where we have some damage, tree branches down, damage to your siding, crops, that type of thing. So that is the definition of a severe thunderstorm. You'll notice lightning is not on it. Lightning is very dangerous and deadly. We don't issue warnings for lightning because every thunderstorm would get a warning. So we would certainly be inundated with warnings all year. We do other things like a special weather statement, maybe a heads up to the media and the marine community out on the boat. We can issue special weather statements or marine warnings for those, but not a severe thunderstorm warning. A couple other definitions, and again, this is good to know as a spotter, because when you're reporting this, you want to be accurate. I highlighted everything in yellow that's important. Tornadoes and funnel clouds. Tornadoes, a violently rotating column of air in contact with the ground. Two keys. It's rotating, it's in contact with the ground. Nowhere do you see there's a low-hanging triangular cloud. Nowhere in there do you see a threatening cloud. It has got to be rotating, and it has got to be in contact with the ground. I'm going to show you some examples later that look like tornadoes, but there's some key words I want you to remember. Rotation, rotation, rotation. A funnel cloud is very similar to a tornado. It is rotating. The key difference is it does not reach the ground. And it may seem real simple to you, but in the heat of battle, when it's dark out, it's thundering in the distance, and you see a low-hanging cloud, some folks in the general public that haven't been to this class will automatically assume tornado or funnel cloud. But you now know, hey, Eric said it's got to be rotating and it's got to be touching the ground if we're going to call it a tornado. And those are some things that we would ask you on the phone as you call things in. So we went over who the Weather Service is, went over some fundamental definitions. I don't want to go too much more into the talk without talking about our website. It's fantastic. No matter where you watch this presentation, if you just go to weather.gov, that will send you to the national page, and you just click on your neck of the woods. So if you're watching from Maine or Kansas, or I know we have a lot of local folks, Jacksonville and New Bern, if you add /Newport or /Morehead City, bookmark that. That is your local page. That's us, that we live right down the road from you. We live in your community. We're making the forecast for you. This is the map you'll see. You can click anywhere on the map to get a forecast. You can enter your city or zip code in the upper left. I know we have folks on from New Bern and Jacksonville. You can click on Jacksonville or New Bern, and then you can say, no, I live in Riverbend, or I live in Piney Green, or I live in Richlands, I live in Stella, wherever you live. I live near the base in Camp Lejeune. You can zoom into the map. There's a green box, and it's a zoomable map, so you can actually set it for where your house is. We've got all the bells and whistles on that website, and again, you're paying for it. We're part of the federal government. You get a text-based 7-day forecast, an icon-based forecast as well, so you can pretty quickly know what is happening with the weather. If you're really into the weather, or you're an avid gardener like me, or you just want to get outside with the family, the hourly weather forecast is your friend. If you scroll down the page, it says hourly forecast, and there's a lot of parameters on there. In this case, we just have temperature, wind, and sky cover. Is it going to be sunny or not? Checked off. So you can see hour by hour for the next 7 days in a 48-hour block exactly what's going to happen. And I know we all have this, and I know we can get information on this. And for the most part, this is not bad, especially on a sunny day. But what this is usually a model, a pure weather model. Nothing wrong with that. That's what we look at in the office. However, in the office, there's a human that has experience, that has looked at those models for years and years and years, and can say, yep, model's right today, or we better tweak things a little bit. South wind, we're usually kind of cool off the water in the springtime. Springtime severe weather, usually more likely inland because of the cool waters of the ocean. So humans at your local office are making these forecasts. The other thing I want to point out, if you scroll down to the bottom of the page, you can get a weather hazard briefing. This is only when we have really bad weather, hurricanes, severe weather threat, winter weather. If you scroll to the bottom, you'll get a PDF briefing on what we think the weather's going to be. It's got a lot of details. These are a couple examples during Hurricane Florence, and this is a winter storm a couple years ago. So this is not a 30-second or 20-second read. If you want to read a couple minutes and know exactly what we think is going to happen from a team of meteorologists, I should mention we've got over 20 of us at the office. This is really your opportunity to sink your teeth into that. We are on social media. We're on YouTube, Twitter, and Facebook if you just search NWS Morehead City. And I need to add Instagram because we are now a test office for that. So any of your favorite social media platforms, just search NWS Morehead City. And you'll notice it's different on Instagram, where we posted pictures of beautiful azaleas outside our office and maybe a beach picture. On YouTube, you'll get things like this, a Facebook Live that we did during severe weather with more audio and video type of capability. So depending on the platform, we certainly adjust on what we want to show. We do not officially have an app, but mobile.weather.gov is a great resource. You can save it and bookmark it, very similar to an app, and it does everything that an app will do. I should remind you that you have a copy of this presentation, because I know I'm throwing a lot of links at you. And tomorrow, I always do a follow-up. You already have your certificate, but I like a nice email follow-up, our phone number, how to report, and all these links that I'm talking about, because I know you're busy with life. Perhaps you got other things going on, so I like to send it out in an email so that you have access to that. So I'm going to hop out for 1 second of the presentation itself before we talk about the Storm Prediction Center and kind of show you the interactive website while we can. So again, weather.gov, in our case, /MHX/Morehead City, or just click on Eastern North Carolina. So here's the forecast I was talking about. We have more people in Jacksonville tonight, so we'll click on Jacksonville. And again, here's the local airport. Here's your icon-based forecast text. And this specific point is where I clicked in Jacksonville. But let's say, again, I live over toward Half Moon. Again, the forecast is not going to change much depending on the weather. Sometimes it's hotter inland, that type of thing. So now I'm going to scroll back down, and now you can see my location is over Half Moon. If you do any hiking or traveling and you go to the western part of the state, you're going to notice a big difference between Asheville and Greensboro, with elevation and things like that. If you scroll to the bottom, this is where you get the hourly weather forecast. So very, very useful stuff. What I recommend is go to the website, zoom into your house, and when you get to this point right now, bookmark it. All the headlines are at the top. You still have that. You have your forecast, and then you have the hourly weather forecast. So I highly recommend just bookmarking your location. Back to our main website, if you scroll down, a lot of our social media, Facebook and Twitter shows up at the bottom. So if you just want to see what we're posting, and here are those icons I mentioned. Here's our weather hazard briefing, SKYWARN class. I'll click on that. We touch on this more at the end, but our upcoming schedule, we have other classes, including advanced SKYWARNs, which I'll talk about. And then we will be adding tropical SKYWARNs here this upcoming summer. In addition, we have recorded training. I'm going to go more into this at the end, but I wanted to talk about it in the beginning. Winter SKYWARN, Cocoa Raws, a whole bunch of training on YouTube, and that is on our main site. I'll send you all the links here tomorrow, but if you just go to our website and click on the SKYWARN tab at the bottom, you will get that. I'm going to step back one. Okay. So I mentioned a lot of websites. One more website to mention that's very good to bookmark is the Storm Prediction Center. It's spc.noaa.gov. They do a general outlook for thunderstorms out to 8 days. In addition, with the local offices, they will coordinate tornado and thunderstorm watches. So very, very good to know about severe weather days and days down the line, or even the current day's information. All right, so that was a lot. Went over the website, kind of laid the baseline of who the Weather Service is. Now we're getting to the nitty-gritty part of the class. What I dare say is the fun part. I love the Weather Service and talking about our website, but it's fun to talk about thunderstorms. So back in the beginning, I mentioned a recipe for watches and warnings, and you can kind of think of it the same way with any type of weather. You need all of these ingredients for thunderstorms to happen: moisture, water droplets in the air. They condense and form clouds and precipitation. You can't have a sunny day and have thunderstorms. Instability, that's fuel for thunderstorms. We'll talk about that in a second. And you need rising air, a lift, a trigger, a lifting mechanism to kind of act on all that. So if you're missing one of those ingredients, it's just not going to work out. And this is why we don't have thunderstorms every day, why we get a lot of thunderstorms certain parts of the year, but other parts of the year, we rarely see them. And this is why. That first ingredient, moisture, that's not the reason why we don't get thunderstorms. We are a very moist area. If you've lived here any summer, it gets very humid. We have a lot of water around us, the Atlantic Ocean, the Gulf of Mexico, all the local sounds. So moisture that's one thing that we're usually not missing. The ingredient that we sometimes can be missing is certainly instability. And I mentioned that just think of it as fuel for the storms. If you have a lot of instability, you have a lot of fuel for bad storms. Low instability, not a lot of fuel for the storms. And instability happens a couple different ways. It's really the difference between warm air and cold air. Warm air is lighter and it naturally wants to rise. So on a very, very hot day, think summertime, it's very hot down here at the surface. And as you go up in the atmosphere, it gets cold. The faster that happens, the more unstable the atmosphere is, because that warm air is lighter and it's going to want to rise faster if it has cold air around it. So that is a very unstable day. Hot and humid, we're usually pretty unstable during the summertime. The other way that happens more on a larger scale is think about all the thunderstorms that we've had in the spring, especially on days where they were really bad. What usually happened on the day of the thunderstorm? It was maybe sunny, but it was probably warm. It's probably humid, moisture. And then what happened the next day? It was cooler, maybe even cloudy and kind of drizzly and not the nicest of days. That's a difference in hot and cold air, kind of over a east-west difference. So in this case, we're really hot locally, but Raleigh, Greensboro, Winston-Salem to the west, cold air is moving in along the cold front. And those are two different ways you can get instability. In the atmosphere, it will look very bubbly. So if you ever look out at the clouds and they're kind of puffy cumulus clouds, not really rising, not bubbly, those are not super unstable clouds. Those are called fair weather clouds. But if they look more like the Coke bottle, where they bubble up, especially as they bubble up into the sky, that is a sign of instability. So in this example, the Coke is the moisture. It could be Pepsi. I know that's up in New Bern, so it could be your favorite soft drink. That's the moisture. If I shake it up, those are the bubbles. That's the instability. So think back to the recipe. We have two ingredients, but nothing's happened yet. We need that last ingredient, that trigger, that lift to, in this case, take the bottle off the cap. And that last ingredient is a lifting mechanism. We usually get this from fronts. This is why your local weather person or the Weather Channel, AccuWeather, Weather Nation, whatever you look at, they talk about cold and warm fronts all the time. And this is the reason why. This is an example of a cold front. Cold air is very, very dense. So in this example, it's moving from left to right, and it's pushing into the warm air, forcing it up and lifting it. Apples to apples, this is where we get our tallest thunderstorms, our most severe weather, because the storms are very, very tall, 50 or 30, 40, 50, 60,000 feet tall. On the top is how a cold front looks on a weather map, and the arrows always point to where it's moving. So cold fronts are a lifting mechanism. Warm fronts are a lifting mechanism as well. In this example, again, we're moving left to right. The upper right graphic is how it looks on a weather map. It's a red line with red half semicircles, and they point in the direction it's moving. In this example, though, on the right side, our cold air is already in place, and it has its arms crossed. It doesn't want to budge. It doesn't want to move. It's very, very, dense. Doesn't want to move out of the way. So as the warm air comes in, it gradually rides up over it. And because of that, you get flatter clouds, stratus clouds, you get rain. They're not very, very tall. So comparing them, usually your more severe weather is with the taller clouds because it can be higher in the atmosphere, colder in the atmosphere. You have more potential for hail, high winds, that type of thing. Can you get thunderstorms with a warm front? Yes. Can you get severe thunderstorms with a warm front? Yes. Can you even get tornadoes with a warm front? Yes. For different reasons, there's twisting or a lot of shear around a warm front. So you can get severe weather, but the clouds tend to be more shallow. So on the long run, they don't tend to be quite as severe. So now you're going to notice a trend. We're going to talk about how to report to us and what. So now we're going to be going over some different types of reporting to our office. The reason why we put this in the beginning is this is probably the most important slide, in addition to knowing who the Weather Service is, how to report. We really want you to do the 800 number. We're going to talk about Facebook, email, Twitter, amateur radio, all unique ways to report to us. But the 800 number we answer all the time. We love Facebook, we love email, but if we're doing 5 other things, it goes to the side. But the phone, whenever that rings, we answer it. So call that number, program it in tonight into your phone. You're going to get a follow-up email. It's on our website. You're going to see this number a lot. But program it into your phone, and you're going to notice a procedure we want you to follow. We want you to call that number, say that you're a trained SKYWARN spotter, what you saw, where you saw it, and when. And for those that are new to the class, you might say, wow, that's some procedure. It's the same thing. If you miss a step, we're going to ask you that question. The reason is if you're reporting tornado or a hail or something urgent that we need to know right away, we need you to get in and out of the conversation so we can take action if we need to. Add information to a warning, call a local municipality, that type of thing. So we don't want you to rush, but we want you to be succinct. And a lot of this is crucial. Where you saw it, where is this weather happening? When you saw it, did you take shelter in your bathroom for 10 minutes? That's fine. And it happened 10 minutes prior. That's important because the first thing we're going to do is look at radar. And if it doesn't match up, we're going to be confused. So it's real important. 800 number, we can ask you those questions. All right, Michael or Elizabeth, Rance or Sarah, we got a couple other folks on. Are you sure it's a tornado? Okay, so it's a tornado because it's connected to the ground. Bingo. We can ask you those types of questions and kind of lead you through it. Another way to report is our email address. It's wxobs.mhx@noaa.gov. Again, you have a PDF of this. I will follow up, and it is on our website. The email is good specifically if you're looking for a way to send us video or pictures. So you call us, you make the report, hey, I've got some video to show you of the hail, send it to our email address. Same thing, who you are, what you saw, where and when. So those are important slides, especially that 800 number. So we talked about thunderstorms, the ingredients that we need, and we put it at the forefront, how to report. Now we're going to get into what thunderstorms can cause in terms of bad weather. And this graphic is very, very useful. I like to back things up with pictures. On the far left is something we call a single cell storm, and on the far right is a supercell. And we're going to go from left to right in terms of severity. So on the far left, the severe threat is slight. You can get severe weather, but it's not as likely. There's something called an updraft, that is rising air in the atmosphere. So in this case, the updraft is kind of weak. Air is rising, it's not all that strong. And one more term is called shear. That's a twist in the environment. If you have strong shear, the storm is more likely to be tilted. If you don't have strong shear, the storm is expected to be very vertical in nature. And I love to show things with pictures because shear and I'm throwing out these different terms. What we're talking about is this is a single cell or pulse storm. And it looks like this. The storm develops, it pulses up, it looks like a good storm, and then it collapses on itself. The reason for that is since there's no shear and kind of a weak updraft, it develops and then collapses on itself instead of being tilted where it could ingest new, fresh, moist air and have some longevity. So that's what it looks like in the field. It's kind of straight up and down. On a cross section of the radar, this is what it looks like. They pulse up really quick. These are your garden variety storms. You see them on radar, you're thinking, finally, we're going to get some rain, and then poof, they go away. And then another one pops up. They're kind of like the whack-a-mole storms. They pop up, come back down, and then another one happens. So this is what it would look like on radar. 5 to 10 minutes, within 10 minutes, they're already looking, wow, this is a great storm, lightning, maybe some hail, indicated by this red. But by minute 20, they are already descending to the ground. Because they don't last a long time, they usually don't produce really, really big hail or a high risk for severe weather. Can you get some gusty winds? Yeah. Can you get some hail? Yeah. Can it be large sometimes? Decent, but it doesn't have a lot of cycles to go through since it's such a short duration. Can you get a tornado? Yes, but all that is on the lower level of the threshold because we don't have a lot of shear to tilt the storm and we don't have a really strong updraft. One thing that is pretty common in pulse storms is to get at least a little bit of hail. So now you're going to notice the next couple of slides, we're going to talk about what you should report. Any sized hail. And if you remember, you might say, well, severe hail is only quarter. Don't you only want to know about that? No. The worst part of the storm may not go over you. So if you're telling me that you're in the, if the radar's showing you're in the weakest part of the storm and you're getting penny-sized hail, I know that the worst part of the storm is producing hail larger than that. So any size hail. If you can, measure it with a ruler or use some sort of reference. That's what we have up on there right now. So at the bottom is a reference like a ruler. That would be fine. Go out after the storm has passed. Go into the yard, find the biggest hailstones, measure them, whatever the width is, and then you call that in. An example might be, hey, we've got a lot of hail, but the biggest ones are the size of quarters. Here's a picture for reference. Again, take away that quarter. I can surmise those are big hailstones, but I might think those are the size of a golf ball because I don't have a reference like a quarter. Whatever you do, do not report it as marbles because marbles vary in size. They're not a known size like a quarter, a nickel, or penny, or better yet, a ruler. So please keep that in mind. So to summarize hail, any size hail we want to know about, give the size of the largest stone, and then certainly want to let us know, when it occurred, your city, and like we mentioned before, when you call in, kind of a standard approach for reporting. So now we're going down that chart a little bit. I mentioned that now we're going to start to increase the updraft. So the air rising is faster, it's more unstable. And we're going to have some shear. And shear is just a difference in wind direction with height or wind speed with height. So if you're going up in the atmosphere and one of those is changing, you can have shear. And that's what this graphic on the lower right is indicating. In this case, it's stronger winds, so it induces a rolling or kind of a spin in the atmosphere. But notice the picture. Look at these bubbly clouds. Remember we talked about the Coke or the soda bottle example? Next time we get severe weather, this spring or summer, look at those clouds. Are they puffy cumulus clouds and they're flat and not really growing? Are they growing up in the sky? And are they tilted? Look at how these are tilted. Because they're tilted, they can last longer. Instead of 15 to 20 minutes and then that's it, they might last an hour. And we don't mean one location, we just mean a line of storms, multiple storms. And when that happens, especially if they go over the same area over and over again, you can get something like flash flooding. So reporting flash flooding, we want to know about something that's significant or pretty rare. So we're not talking about the ponding in the low spot in your road. We're talking, hey, I've lived here for a couple of years. This happens maybe once a year, once in a while type of thing. And give us a description. Are roads becoming covered? The creek behind your house, hey, it's never been this high before, or last time it was this high, we had this much rain, that type of thing. We want to know how deep the water is. I do not want you going out there measuring. Use your eyes up to the car's hubcaps, up to the car roof, up to the stop sign, that type of thing. For those that live along the coast, we're kind of getting out of nor'easter season into tropical season, so any type of coastal flooding, how far above normal? If you have a staff gauge on your dock, how far above the normal height of the water, those types of things. What's being inundated? This road is covered, this intersection is covered, that type of thing. If you have a rain gauge, that would be really useful to kind of quantify how much rain fell. And we say about 2 inches is our rule. We're not going to complain if you call with 1.5 inches of rain. All we're getting at is, you don't need to call with every sprinkle. But if we get 2 inches in a real short period of time or over the day, give us a call and let us know. I want you to consider a program called Coco Raws. This will also be in the links that we provide. This is something I do every day with my son. He's really into it. The spotter program is call us if you have bad weather. Chances are you're not going to call us because you're not going to get bad weather at your house, which is a good thing. Cocoa Raws is a little bit more of a commitment. Between 7 and 9 every morning, you make a report. If you get the app, which is free on your phone, it takes you 30 seconds. It'll take you longer to walk out to the gauge to check it. If it doesn't rain and it's 0 for that day, it'll take you 10 seconds. So real quick. You go to the website, you can order the gauge, you can take training. We have local training, where to put the gauge, how to read the gauge, all that kind of stuff. So you can either view our training, or they have online training right now. Set it up and then start recording. Really good if you're into the weather to do this program. Some questions we get are, hey, I've already got a Davis weather station, I've got an Ambient Pro, I've got a Weather Flow, all great stuff, but we really would prefer that you get one of these plastic rain gauges for the Cocoa Raws program. The reason is they are the most accurate. The ones I just mentioned usually use a tipping bucket or some sort of sensor. It does a decent job, but it can under or over represent how much rain fell. The good old-fashioned cylinder, where you got to go in the yard, look at it, empty it, it's a little more work, but it is more accurate. So definitely consider that. And if anybody is a Cocoa Raws observer now, send that to me in the questions. Interact with me and let me know, because we usually have a couple on, and they might be able to speak about the program a little bit. So we started off with pulse cells, weak updraft, not a lot of shear, low threat for severe weather in the vertical. Now we're increasing the updraft. We're increasing the shear, so we can get multiple cells or lines or heavy rain, because the duration is half an hour, a couple hours. And we don't mean in one location. We just kind of mean the life cycle of that individual storm. In this case, another threat are winds. This is called a bow echo. Things in Mother Nature don't just happen for any happenstance. There's a reason it's bowing out. And that reason is strong winds are pushing that air out. This is what it would look like in the field. This is what's known as a shelf cloud. Doesn't always mean severe weather, but that's the rain-cooled outflow of a thunderstorm. At the very least, the winds are going to pick up and shift around. So that's good to know. This is a beautiful picture of a shelf cloud locally. This is a couple years ago now, down in Fort Macon, as viewed by Harker's Island, or excuse me, this is as viewed from Harker's Island, but that same storm produced an 82-mile-per-hour wind gust in Fort Macon. I remember, because I was working that morning when that came through. It was kind of a morning thunderstorm. So that's what a shelf cloud looks like. And you see these striations kind of in the clouds. It's hard with a still picture, but that shows the slight rotation of the storm. Sometimes when people hear rotation, they automatically think tornado. And yes, you do need rotation on a small scale for a tornado, but a true thunderstorm, miles and miles across, is slowly rotating if it's a severe thunderstorm. That's kind of the nature of it. So I turned the sound up a little bit. Sometimes the sound doesn't play well through this software, but that looks like a tropical storm or a hurricane, doesn't it? You see the trees bending over, the heavy rain, and the trees snapping. This is a microburst. It is, in a thunderstorm, you have an updraft that goes up, and then you have a downdraft that comes down. If it's a run-of-the-mill downdraft and thunderstorm, it's a 20, 30-mile-per-hour wind. If it's a severe downdraft, it's a 60-mile-per-hour wind. And if it's a microburst, it could be 80 to 100 miles per hour. And we mentioned this because wind damage is one of the big results of thunderstorms in terms of property damage. So we want to know about this. What is damage? Trees down, power lines down. How big are the branches? Was the tree dead already? So maybe the winds weren't as strong. Is it a Bradford pear? Not as strong of a tree versus an oak, something to that effect. If you have an anemometer, let us know what the wind speed is. Not too concerned with estimating wind speeds. There's the Beaufort scale, but it's hard to estimate wind speeds because a lot of times, you know, I guess the example is it's real windy out and you think it's worse than it is, but you really need some at least twigs or small branches down if you're talking 40 or 50 mile per hour winds. So a lot of times people will say, oh, it's a 60 mile per hour wind, but they don't have any damage. So Usually not too concerned with the wind estimate, usually more curious what was actually damaged, because that tends to be more of an accurate report. So just a little timekeeping. We are at 7:16. We're on the home stretch. We should be done in the next 10 minutes, and then we'll turn it over to you for questions. Another way you can make a report is Facebook. But again, if you're just joining us, highly suggest the 800 number. Facebook, like email, it's a good way to send video or a picture, but do the same procedure. Give yourself some credit. It's a beautiful spring night. You sat through an hour almost training. Make sure you identify yourself as a spotter. So we're at the end of the thunderstorm scale. At the one end, weak updraft, weak shear. Then we increased it some, so we got lines and multiple storms, flooding, maybe some high winds. Now at the far right hand of the spectrum, strongest updraft, again, that's air rising, strongest shear. This is a full-blown engine, a full-blown supercell. This is what it looks like in a textbook. On the far left, you have very strong air coming into the storm itself and rising. And then on the front side of the storm is the dark side of the storm. That's where you get your strong winds and your hail. So you have air ingesting on one side, just like an engine, and then you have an exhaust, just like you would with a car vehicle, on the other. This backside is called the precipitation rain-free base. This is where wall clouds, which can be the precursor to funnel clouds and tornadoes, are most likely. This is the ideal setup. This is where we stop for the basic class, kind of whet your appetite, focus more on the principles of reporting, and then in the advanced class, we go more in depth on supercells and things like that. So that's what it looks like in a textbook. This is what it looks like in, on a radar. This is an example of the hook echo that you could potentially see on radar. What it's showing is this is a reflectivity mode, so the precipitation is actually wrapping around the circulation. Doesn't always necessarily mean tornado, but if you have other things that look favorable, it can certainly mean that. This example, if you live local, was the crazy year of 2018. Not only did we have the snow in January, which I liked, not so much the cold. Florence, we'll never forget that. And in that November, we had tornadoes. So it was a pretty wild year, one that we do not want to see again. Speaking of Florence or Dorian, tropical tornadoes are a common thing. Think about it. No matter if it's a Cat 5 or just a tropical storm, the thing is spinning, it's rotating. And because of that, it's very likely it has a potential to produce tornadoes. Usually they're weak, usually they're short-lived, and usually you should be hunkered down. You're not out shopping during a tropical system, but they can produce some enhanced areas of damage for sure. We get a lot of water spouts around here. Water spouts are tornadoes on water. A traditional water spout is what these pictures are, and what they are is same concept. You have moisture, you have some type of lift, and you have the instability that is going on. Sometimes they can be caused by a thunderstorm producing a tornado and they cross onto water. Anything on water is considered a water spout. Usually they tend to be weaker. You don't have gigantic tornadoes on the water because they really need that warm air from the land. However, if you're on a boat, any type of water spout is dangerous. So we mentioned this in the beginning, tornadoes and funnel clouds, you have got to have rotation. So that's probably the first thing we're going to ask you, in addition to where you are, if you don't tell us. Be real clear about the time. If you took shelter, that's no problem. Safety first. Just let us know that, because at this point it's down the road and we want to be clear. And if you live along the coast, water spouts are small in nature, so the radar sometimes have difficulty seeing them. So any of those reports would certainly help. We mentioned Facebook already. Twitter is another way you can make a report. Again, 800 number first, and then Twitter, Facebook, email to send us follow-up pictures and or videos. So I've done enough talking. We got about 10 minutes left in the class, so a couple quiz questions. Don't worry, we're not going to pass fail you on whether you get that certificate or not. This is just reinforcing what we want in terms of rotation, connection with the ground, that kind of stuff. So I'm going to show you the pictures, stare at them real closely, Then I'm going to give you a chance to answer this question for that. So if you stare at this question or the pictures, are these funnel clouds or not? And the big hint is they are not rotating. So let me load this one up. So you stare at that picture. They look kind of triangular. They're dark. They're hanging low. Are they funnel clouds or not? But they are not rotating. Let me see here. So you should see that poll question. Is this a funnel cloud? Is it yes or no? And even without seeing that picture, a huge hint, and I think a lot of you are getting that hint, is it is not rotating. So remember, that picture looked crazy. Triangular, dark, hanging low. All right, so most have answered. All right, let's see here. We're going to close. We're going to share. So 50-50 split. So is this a funnel cloud? And the answer is no, it is not. So those that put no, you got it correct. And you might say, well, Eric, you know, that picture looks crazy and it looks very ominous. And I would agree with you, but it is not rotating. So remember, you have got to have rotation for that to be a funnel cloud. So yes, it looks crazy. These are called scud clouds, scattered cumulus under deck. You don't need to know that, but you need to know that this has got to be rotating. If you were to see this in a video, it'd be kind of low hanging and it would just be moving along. So not trying to trick you, just again, reinforcing rotation, rotation, rotation. You've probably heard of the EF scale, how we rate tornadoes. This is based on damage. So we go out on a survey and we look at the damage and we use the scale to determine how strong the winds were. So that's one part. How strong were the winds? Then the second part is pattern, pattern, pattern. And the pattern tells us if it was a tornado or not. So in this case, if it's kind of a chaotic path, a narrow path, and the trees are facing inward or in convergent pattern, that is indicative of a tornado. We're not really into looking at tree branches or twisted trees because that's more about how the tree failed. We really like to look at uproots because an uproot falls the way it was blown. So in this case, you can see clear convergence. This was a tornado. For a microburst, the trees are more, you could say in one direction, but it's more flattened out. They can vary in direction, but if they're divergent, a fan shaped, that is more indicative of a microburst. So I don't like to say same direction. I mean, it is going in the same general direction, but it's fanned out. So I took these pictures specifically to make that point. And the winds can be as high as 100. And that's an important point because sometimes when we do these surveys, folks will say, you know, hey, it had to have been a tornado because there's a lot of trees down. Remember, we look at two things. Wind speed, that's separate. Pattern is what determines if it's a tornado or not. One more spotter quiz, and then we'll wrap this up. Another picture, this one you do have to stare at, and I will give you a hint, it is rotating, because I know it's hard to tell from a still picture. So it's gonna be one of these because it's rotating. So you've got this column of air. So now you need to determine, does it touch the ground, and that would mean it's a tornado, or is it a funnel cloud, which would mean is it a tornado if it's touching the ground, funnel cloud if not. So this one, answer in the question section, and I'll kind of wait for some answers to come in. So is this a tornado or a funnel cloud? Again, the key with this is it in contact with the ground? So we got a couple answers coming in. So Elizabeth says tornado. Sarah says tornado. We got a couple more coming in. We'll give it about another 10 seconds. All right, a couple more coming in. And Elizabeth and Sarah, I would not call your names out unless you were right. So you are right. So the reason why it is it's in contact with the ground. You can see the circulation. In this case, it's debris or dust or the condensation cloud. So again, not trying to trick you. Rotation, rotation, rotation has got to be rotating. And then if it's in contact with the ground, it's a tornado. If not, it is a funnel cloud. Last thing I want to mention about reporting is something called MPing. It's a way that you can report precipitation type and damage. It is useful. Still want you to call the 800 number because we can get a lot more information that way. This slide is a good reminder that we want you to call right away when it's safe. But if you arrive at your home many days after, let us know what's going on, because follow-up reports can be helpful. You know, let's say you got a lot of trees down in your yard, you've been gone for a week, we can narrow it down what day it happened and maybe fill in the gaps. So please call that 800 number, even if it's the damage occurred a couple days prior. There's a big myth that we already know. I mean, you know, look at all this damage. There's tons of trees down. How could somebody not know about this? Sometimes we don't. The emergency crews are there to help people. They have a lot of tasks to do. They can't always call and relay that information back to us right away. Their number one priority is saving people. So please give us a call if you have bad weather where you are. And this is an example of one of our worst tornado outbreaks. This is back in April 2014. We are kind of coming up on our peak. April into early May is our peak of the severe weather season, even though we can get storms year round. So to summarize, again, tornadoes, hail, flooding, heavy rain, we want to know about it. Please call us. This is a summary of the procedures. We've got our email, Facebook, CocoRaws, but 800 number is the best because we can ask you questions. If you forget something, we can ask for follow-up with that. When should you not call us? Not a lot of times, but if it's a non-severe report that doesn't have anything tangible. Hey, it's raining hard. There's a lot of lightning. It's really windy. That's useful in the sense that, hey, it confirms what's happening, but there's no hail size, wind damage, that type of thing. So anything non-specific we don't need to know about. And lightning, we have a lightning detection software system. So we do know about lightning. That's not something that you need to follow up with us about. As we conclude this class, we really want you to consider being a year-round spotter. The chances of you getting a tornado or hail or high winds is low, which is a good thing. The chances of you getting rain or snow, very high. So that's why we want you to consider CocoRaws. Consider reporting snowfall next winter. So just some tangibles on snow, take a couple measurements, nearest 1/10 of an inch, send it on into us. And that leads us to the last part of the class, which is something I showed you in the beginning. This is basic SKYWARN, tornadoes, high winds. The follow-up to this is the advanced class. That goes more into the science. It's kind of our gift back to you. We have a lot of people that are really into the science, and they want to know more. So we want to educate them on that. The sister class to this is the winter, which is in the fall and winter time. Look for a flood and tropical class, usually in the summer and early fall as we get into hurricane season. All of this information is on our website. All of this information will be sent to you in an email. And then a couple times a year, I send a spotter email, remind you what to report, remind you of upcoming training. So you do get a lot of good information sent to you throughout the year itself. One important thing to point out is we do have training year round. So if you have any issues, if you had any issues tonight, you had to step away, you're just logging in, oh, I missed it all. You didn't miss it all. We put it on YouTube. Some of our older classes are there, and then we're going to post this here shortly. So don't worry if you missed any of this. So that is it. We're right at the hour mark. So that means I talked enough. My email is at the bottom. You are welcome to send me any questions or feedback. If you like these classes, let us know. We will certainly do more. In the meantime, look for that email from me tomorrow.